All right, today let's look at the part two of how to do a wear analysis inside LS-Dyna. So in part one, what we did was we basically look at a deep draw analysis in which the die is basically uh, uh, there's basically lot of sliding and pressure along this interface right here. And the goal of the simulation is to try to figure out, how can we model what happens after 10,000 cycle, 20,000 cycle, 30,000 cycle of a deep draw process. How does that affect the wearing around the die, and how does that change and how that then in turn changes the shape of the piece that we're generating, right? So this is the end of the step one of the analysis, and what we wanted to do now is to figure out how can we post process and then continue an analysis with the deformed shape of the die, and to look at what happens to the die after say 10,000 cycles. Okay, now so this is the step one. What I have prepared so far is that this is the in essence what's happening in the background. So I'm gonna actually just gonna fast forward to the portion of the video where you can sort of see what's happening, right? So they say this is the pre-deformed shape where after only one cycle, right? We're looking at a shape of the die just such as this, where there isn't a lot of wear yet. Now what we can do inside Atlas Prepos and with Atlas Dyna is to sort of estimate based on the Archer's wear law what happens to the geometry after 10,000 cycles, right? So if I were to compute 10,000 cycles, you can sort of see there's a very clear deformation that happened. Yeah, you see this no movement right here that we're seeing on the screen. This no movement is essentially an estimation based on the wear depth calculation from the interface force file. We're essentially calculating the nodal movement directly based on 10,000 cycle of the deep draw process. And then this is a deformed geometry that we can then save and load to a second stage of the analysis for the next 10,000 cycle, right? So what I'm going to demonstrate today is how to quickly do three different 10,000 cycle stages where we look at what happens after geometry after the first 10,000 cycles. Then we're gonna import the deformed shape due to the first 10K cycles into the second stage to do another wear analysis, and then we're gonna calculate wear again to see how that transfers to the next 10,000 cycles. Right, so this is a progressive calculation in which we can look at the wear after 10,000, 20,000, and that number can be any number you wanted to have. It doesn't really matter what it is, right? And that's what we're gonna try to do today. Okay. Now I put together some slides to quickly summarizes everything we needed to do. This is the model that we ended up with last time, right? I'm not gonna make a lot of changes to the model, but what I like to do is to go over what happens with a slide. What I also like to do is to demonstrate a few key steps that we have to take to correctly do this, right? I actually took a while for me to figure out how to do this, because there's a bug with the contact card, and then there's other issues that I had to overcome to figure out what to do with this. But I'm happy that I'm able to figure it out. Then I'd like to share that in my YouTube channels. Okay, so the most important thing to understand, right? So the interface Spring back Dyna, this is the first thing. This is the card that is going to generate the so-called Dyname geo file. This Dyname geo file is going to contain the initial contact wear card, which is then going to define how much of this nodal movement that we saw earlier. That nodal movement is essentially defined by the initial contact wear card. This initial contact wear card is essentially generated inside this dynamic geo file. And this dynamic geo file has the nodes and elements that we need to import to the next stage. So to generate this, we have to make sure our fs split, this f split file is going to be a 1, which allows us to separate the dynamic geo from the rest of the geometry, right? So we need to make sure this happens first. So this is step number 1. Step number 2, we want to make sure that the soft is either 1 or we remove the option A and option B of the contact card. Right now there is a bug with soft equal to 2, which does not allow the initial contact word to be generated. So that's a bug that's kept me for a while from figuring out what to do. And then, of course, just as I explained in part one, we have to make sure the SPR and MPR are set to 2 for the contact pair. In this case, I'm only interested in the contact set, so I only have one set being set to 2. This is what going to allow us to generate the wear data into the initial contact wear card. Okay, and then What happens here is this, right? So let's say we have this model that we've basically fully completed, right? So I have everything set up correctly. Now notice I have 10,000 NCYC value here. This 10,000 is going to indicate the 10,000 cycle that I'm interested in calculating. So what I'm doing here is I'm going to run an analysis for one cycle, calculate how much wear is due to that one cycle. And in post processing, I'm going to generate a nodal movement based on a 10,000 cycle estimations, right? And that's what you saw earlier in that video is that based on 10,000 cycle, I can look at how much nodal movement I have in that contact interface. Now I can set this number to 5,000 or 1,000 or 100. You're just gonna have a different amount of nodal movement, right? And this is essentially like a multiplier to how much wear depth we have on a single cycle. We're just going to multiply the single cycle value by this number to get a total estimation of 10,000, 5,000, 1,000 cycle of wear, right? So this number is very critical. Of course, I want to set my FS split to 1 to give me my Dyna geo file. Okay, so what happens here is that, I'm going to write out this input file, right? This input file is going to be basically the starting point of my model. I'm just gonna create a location called YouTube, right? I'm just gonna call this the YouTube test.k. Okay. Now in the YouTube test.k, what happens in here is that I wanted to sort of showcase this process because it's a little tricky, and it took a while to figure out what the best workflow is. But like I said, my channel is all about figuring out workflow and figuring out the demonstration of a modeling approach. So this is a very good example to do so. And of course, the first thing we want to do is to make sure we set our contact to solve to 1, and I want to set our SPR to 2, and I'm going to set MPR to 0, right? So that only the SPR, which is the contact side of my which is the die piece is going to be written out in the final model. And now if you look at this model, this is basically the only change we have to make. Now what I also need to do is to create a new file. I'm going to call this file a LS-Dyna file, right? And then I'm going to save it. I'm going to call this the geometry original YouTube. Okay. Now within here, what happens is that I'm actually going to look for the nodes and elements that are part of my original model setup, right? So you see in most other designer model, your nodes and your elements are written in these two cards, right? These are basically your mesh, which in essence is also your geometry, right? So what I like to do, and this is something that Workbench does not do it for you, right? But what I like to do is to separate these two files or these two portion of the input file from the rest of the system by basically cut this into the original geometry. So now this whole thing is all this geometry original that YouTube has is essentially my node and my elements, right? It does not have anything else. Okay. You see, all this thing has is my nodes and my elements. So what I need to do here is I'm going to type in keyword to start, and I'm typing in to finish. This is what allows LS-Dyna to recognize this as a separate input file, right? And then I'm gonna save it. So now my geometry original YT is now part of my, is not a separate file. And on this side, I just have to make sure I clean it up. So I removed all the nodes and elements, and I'm gonna clean it up. And now this all goes away. Now I'm actually going to do an include here later, but I'm not gonna do that yet, right? So I'm gonna add an include because whatever I'm doing, I'm gonna include the geometry back here, back into my original file. Okay, now I'm gonna drag it to my other screen and show you this inside Atlas Prep Post now. Okay, so what I have here is I'm gonna drag this geometry original file into my Atlas Prep Post. And what you're seeing here is that, basically there is all my geometry from my model is here, right? I don't have anything else. And then what I'm going to do here is that what I wanted to do is to separate out this brown piece from the rest of the body, right? So I want this brown piece to be a body that I want to be able to write out individually. So what I'm going to do here is that I'm going to go ahead and delete everything except for the brown body. Now this is my die. Okay, I'm gonna save it, save, save as keyword, and then I'm going to call this call this the geo die youtube.k. Save. All right, now I'm gonna restart the file. I'm not gonna save my original input file because I want my original input file to remain intact. And what I want to do now is that I'm gonna drag the geometry original back in here again. And this time, guess what? I'm gonna delete only the die piece. So now I have everything else in here except the die piece, and I'm gonna save it again. And this is my way of sort of separating the file, right? I'm gonna call these the geo other youtube.k. Okay, so notice what I just did, right? Notice what I just did. I'm gonna go ahead and restart Artist Purpose again. Right, not save anything. Now notice what I did here is I now have a geo die and a geo others. So guess what happens if I drag the geo die in here? All I see is a die, right? Now guess what happens if I drag the geo other in here? All I see is everything else except for the die. Now remember what we're interested in doing in this model, right, is to understand how the die itself wear over time, right? And this is why I'm separating them out because all I care about is replacing this geo die file with the deformed shape from from each stage of the analysis, right? So that I can actually analyze the progressive wear of a part every n cycle. In this n in this case is equal to 10,000. Okay. And now once this is done correctly, this is where I'm going to look at my include file, right? So this original YT is good to go. I don't need it. But what I need to do here is to copy my 2K file, which is the 2geometry file I just generated, into my uh, my model, right? You see now here this is. And then once this is done, I can basically submit this input file to solve. Now, of course, this thing is gonna take forever to solve, so I'm not going to solve it during the video itself, right? Now I can just basically go to the YouTube test and solve this model. It's gonna basically solve this model by looking at the original input file, and then it's gonna import the geodie geometry and it's gonna import the geo other geometry. Now all the boundary condition we generated, right? Everything that we've done is exactly the same as before, right? The node number didn't change, the element number didn't change. All we did was separating the geometry file from the rest of the model, and we're recalling them in the include file. Now, what the reason we do this is, right? So I'm not gonna solve it because if I solve it, it's gonna take like 8-9 hours to finish, right? So I already prepared the model. I'm just gonna demonstrate to you what happens, right? So what I have here is a where, which is stage one, right? So in this case, when the full model finishes, right, I'm going to load this into LS Purpose just to show you real quick. Okay. I'm going to load the first stage in here. Now you can sort of see in the first stage, I have my D3 plot, right? And then I also going to import my interface force from the first stage. Okay, and then all I'm gonna look for in this case is this piece right here, right? So let's just look at the wear depth, right? And then you can sort of see the wear depth after the first run is very small amount that you can see there. Now, if I want to look at just the say for example the effective plastic strain, I can do that. I'm gonna cut a section to it. Bam. This is what I was showing in the video earlier, right? You can sort of see there is a lot of sliding in the model right there. Sort of you can sort of see this is what happens when we're running this model. It's gonna take a while to load. Okay, so once this is done, right now this is the first stage, right? So if you look at the first stage in the file itself that's generated, what you notice is that there is a file called a dynamic geo. If I can find it, there's a file called a dynamic geo, which is right here. You see this dynamic geo file? I'm gonna take this dynamic geo file and then I'm going to take my original K file, which is my full draw stage one, and I'm gonna take my geo other and then geo dynamic geo. I'm gonna take it into where stage two. So in where stage two, I already completed it, but I'm gonna show you as a demonstration in the video here, right? So where stage two YouTube. And then what I'm doing here is that you can see I have now these three different files, and let's see what these files are, right? So this dynamic geo file, right? You see, this is not a K file. So the first thing I'm gonna do here is I'm gonna rename it stay from stage 1 K. Now you see this is not a K file. Now let's see what's in here real quick together. Okay, this is so we understand what's going on with this wear analysis. You see what's in here is that forget about this one. This is the nodes. This is the initial contact wear. Now this initial contact wear card is essentially what allows us to describe this value right here are the wear depth, and these are the nodal coordinates x, y, z and this is the node number. And it's basically telling us how much each of these nodes from 9569 all the way down to whatever is going to move in the XYZ directions, right? This so the in this card, this is where we're going to calculate what happens with 10,000 cycle of wear. All right, so if that's hard to read, let's go ahead and look at this in the context of LS prep post. This is what I showed in the earlier video, right? So what I'm gonna do here is that I'm going to take the stage two. I'm gonna take the dynamic geo from stage one. I'm gonna drop it in here. I probably crashed it, so give it a second. All right, so this is the dynamic. I'm actually gonna restart it. Okay. All right, so I'm gonna copy over the dynamic geo from stage one, and you see all I have in here is just part. You can see a little bit of deformation. That's because due to the stage one, there is a small amount of like deformation that happened, and that's normal. Now what happened here is that if I go to the wear tool, right, you can sort of see now I have a stage one being calculated here, and if I click on resultant wear and then click on preview, now notice what happens once I click on compute. You see all these nodal movement right there that just generated, that came from the initial contact wear card, right? It tells us all due to the wear depth calculation that was generated, multiply that by a 10,000, and a 10,000 happened in the NCY in this card right here, right? There's a NCYC right here. If it's 10,000 in the original model, you calculate that by 10,000, and that's why you'll see all these nodal movement right here. And I'm gonna smooth it, so you get a decent contour. You don't have a really zigzag sort of like a nodal element level deformations. And this right here, I'm gonna generate accept. Okay. Now when I accept this, I'm gonna save this keyword. I'm gonna call this where from YouTube changed. Okay. .k save. All right, now guess what happens once I exit this out. So you see now there's a file called a dynamic geo from stage one change. This is the one I just generated. Now if you look at this one right here, now this one now has the deformed shape of my wear model, right? So this right here, this geometry file with the mesh and the nodes, which is this file, is what we're gonna introduce into the stage two of the analysis, right? So in stage two, we have our uh, full stage one model, right? And then so instead of calling geosty stage zero, I'm gonna do basically call this the dynamgeo stage one change.k, right? Now this model is gonna reference all the geo other, which is everything except for the die, and it's gonna reference the deformed die shape. And then together, I'm gonna solve this model again in LS run, right? Now, because all the things that change is just die itself. Every call the contact definition, the boundary condition did not change. The model will run again, and then once that's done, you're gonna have a stage three, which is essentially these right here, right? So in stage three, you basically have so once you finish stage two, right, you're gonna have another dynamic geo file, right? You see this dynamic geo file. I'm gonna take this, and I'm gonna go to where stage 3 YT. And if you think about what I just did, I'm basically just repeating the process from the first analysis, and then I'm just gonna do it again with the second analysis, right? So I'm gonna copy these two files over, and then I now have the same geo. Now this dynamic geo file, I'm gonna call this the stage 2 from stage 2 .k, right? Now if you look at this file right here, now this is gonna have all of the initial contact wear definition from from the deformed shape from the first 10,000 cycle, but now it's gonna have the second 10,000 cycle. So guess what happens? I'm gonna repeat the same process, right? I'm gonna take it over here, and I'm gonna load it over here. And now you see that it starts with a deformed shape, right? Now if I were to go to where again, now you see now I have a stage 2, which is the second 10,000 cycle. And if I do a preview and compute, bam, now I have the second 10,000 cycle. So what happened to the geometry after the second 10,000 cycle is like this. I'm going to smooth it. And then guess what? I'm going to file, save keyword again. And then I'm going to call this uh, changed.k. Save. All right, I'm going to restart LS post so I can see the change that I just made. Oops, sorry about that. Now you see now I have this change file. Guess what? This change file is gonna look at the same the new geometry from the second 10,000 cycle. So no, this is the geometry after 20,000 cycle of wear, right? Now, lastly, but not least, I'm gonna take this file over here. I'm gonna change this to, instead of called DynaGeo S2, right? I'm going to call this this I'm gonna call this right here. 1 second. I'm gonna call it this way, which is going to be suppress, comment that out. So I don't know what happened there. 1 second, let's try it again. I'm gonna comment this out, and then I'm gonna bam, okay. And then guess what? I'm gonna solve this file. Now it's gonna give me the next 10,000 cycle. Now I'm gonna go to 30,000 cycle from there. You see what's happening? So I can basically repeat this process as many times as I want. And there is a way to write a script to do this for as many 10,000 cycle increment as you want. And then you can look at how your structure is going to undergo wear based on the Archer wear law for each 10,000 cycle increment. And then we can also change the NCYC parameter to instead of doing every 10,000, you can do every 1,000, every 500, and so on and so forth, right? So the key here, right, as I demonstrated, is that this parameter defines how many cycles we do, and we're going to go through the LSPP where application tool to change the shape of our geometry, save it back out, then use it include file to include the deform shape for the next stage of the analysis. So you do this over and over and over for as many increment number of cycles that you want to evaluate how the wear how your geometry is going to change based on the amount of wear that you have in the model, right? So for example, for the geo top body, bottom body, and original, right? These are the original files. This is the main file. I can base for each wear cycle. I'm just going to use the include file to include the geometry back into the main model, and that allows me to basically, if you look at what we did here, right? This is my main file. This is the file from the previous stage. I'm going to use the LSPP to do the wear analysis, wear post-processing, write on an updated stage 2 file, include that into the main file, solve again for stage 3, and so on and so forth we go, right? The geo other does not change. The main model does not change. Main model has all the boundary conditions, the control cards, and the database cards or whatever. The geo others has every other geometries. Only the part of interest is the one we want to isolate, then keep updating as we go through each cycle of the wear analysis. Okay, and then you just remember, right? We can before wear we have this, after wear we have this. We're doing this inside LS prep post, and then once we generate that, we'll click smooth and click accept. It's gonna generate an updated LSPP LS K file, and that becomes our updated geometry, which then we import back, right? So over different cycles, you can do first run, second run, third run. Each of these run is not one cycle. Each of these run is the NCYC number of wear cycles, right? So that can be 10,000, 1,000, 500, 100, whatever you want, right? And I made the wear model very sensitive to the number of runs so that I can get a really like a conspicuous response, right? So in reality, you want to look at the actual wear law you're working with. So in LS-Dyna, we have a Ocker wear law. We can also write a user subroutine to get a much more precise definition of wear, and that's where the wear analysis becomes really useful. And then we can automate this entire process with a script, which is going to really help with the actual workflow in a larger project. Okay, I hope this is helpful. Thank you very much.